In today's lesson, we'll be learning about Pythagorean theorem. In a previous lesson, we learned about the right triangle. The longest side of a right triangle is called the hypotenuse, while the other two sides are sometimes referred to as legs. Take a close look at this right triangle. The hypotenuse is 5 units long, while this leg is 3 units long, and this leg is 4 units long. Could there be a relationship between the sides of a right triangle? I've gone ahead and drawn a square on each side of this right triangle. This square has side lengths of 3, this square has side lengths of 4, and this square has side lengths of 5. Let's find the area of this green square. If you recall, the area of a square is length times width, which means it's going to be 3 times 3. 3 times 3 gives us 9 units squared. Next, let's find the area of this blue square. Again, the area of a square is length times width. Therefore, it's going to be 4 times 4, which is equal to 16 units squared. Last, I'm going to find the area of this red square. Again, the area of a square is length times width. Therefore, it's going to be 5 times 5, which is equal to 25 units squared. I want you to take a minute to think about these areas. Is there a relationship between the area of the green square, the area of the blue square, and the area of the red square? Well, you may have noticed that 9 plus 16 equals 25. In this diagram, you may have noticed that instead of numbers, we have A representing the length of this leg, B representing the length of this leg, and C representing the length of the hypotenuse. Based on what we saw earlier, we know that the area of the green square plus the area of the blue square is going to give us the area of the red square. As an equation, this can be written as a squared plus b squared is equal to c squared. In conclusion, Pythagorean's theorem is a squared plus b squared equals c squared, where a represents the length of a leg, b represents the length of another leg, and c represents the length of the hypotenuse.